All right, this is a Chapter 10 review for the final exam. I'll write that down. This is Chapter 10. This will be very quick. This was a short chapter on all review topics for you in pre-calculus. We were just solving systems. A system is two or more equations. So here's a couple of systems. There's a system. We have a couple of equations. So we have options of substitution, elimination. You can also graph. So in this problem right here, maybe you want to use substitution because it's really easy to get this y alone right here. So maybe you want to get that y alone, you'd take this negative x squared and send it to the other side by adding it. So then you'd be left with y equals negative 6x plus 9 plus x squared when you move that x squared over. And then you could take this negative 6x plus 9 plus x squared and stick it in this other equation wherever you see a y, and that's the idea of substitution. And once you plug it in there, you'd end up with a quadratic where you'd only have one variable, which would be x, which would be wonderful, and then you use your skills, because you have serious skills, to solve a quadratic by either factoring quadratic formula or whatever it is, and then you can solve it from there. This one here I would probably use elimination because I see that they're lined up pretty nice, so maybe I want to multiply this equation by negative 3. If I multiply that equation by negative 3, good things will happen. I'll end up getting negative 2x minus 3y equals negative 9. And the top equation I leave alone like yellow snow, and I end up with 2x plus 3y equals 8. And if we add up these equations, the 3y's cancel. Oh, so do the 2x's. Nice. If everything cancels, then you end up with 0. So normally just one of them cancels, but in this case, everything is going to cancel. So you end up with 0 equals negative 1, which is not true. If this is not true, there is no solution. And then I really wanted you in this section to understand what was going on. This is a line. This is a line. The answer is the intersection of those lines. If there's algebraically no solution, then graphically, we must have had a couple parallel lines. So we probably had a couple parallel lines that never cross each other. So there is a chance in a system to get no solution. That'll occur when everything disappears and you end up with a false statement. If you were at the end, let's suppose we ended up with a true statement. If we ended up with like 0 equals 0 or 7 equals 7, now the two lines must be on top of each other. So the answer would just be one of the lines, because whatever works in one line would also work in the other. So there's a chance that they're both on top of each other as well. All right, so we did this up here was substitution. This I was showing was elimination, where we try to eliminate a variable. And then in number 3, it says algebraically or graphically. And we could solve this one algebraically, but you'll have your calculator the entire time for this final exam. So you're like, man, could I solve this graphically? Well, to solve it graphically, you just graph both of these on your calculator. So we need to get y alone. So y would equal 12 over x. You quickly graph it on your calculator. 12 over x would look something like this. You'd get a rational function that looks like that. And then if you graph this equation, you get y alone. I'm going to move it over on the right hand side. We get y equals x minus 3 by moving the 3 over. X minus 3 has a y-intercept of negative 3 and a slope of 1. So it looks something like this. Well, then the answer to this problem is wherever those two functions cross. Okay, this is the idea of solving systems. We could really graph them and find their intersection. So that point right there and this point right here would be the answers. And you need to be able to use your calculator to be able to calculate those intersections. You can solve this one any way you want. Hopefully you all know back from chapter 1 that that is a circle. This is the equation of a circle with a center at 0, 0 and a radius of 25, or no, 625, square root of that? Yep, 25. And then this one is a line. So where does a circle and a line meet? Probably in two places, which it will. But to graph this on your calculator, it's a little difficult because of the y squared. So remember, if I tried to get y alone there, it would say y squared equals negative x squared plus 625. I would take the square root of both sides and get y equals the square root of negative x squared plus 625. But then whenever I take a square root of both sides, the alarms go off in your head, and you know it's plus or minus. So really, when I type this in my calculator, I'll have to type it in as two separate functions. I'll have to type in y equals the positive, or just don't put anything there, the square root of negative x squared plus 625. And if I graph that on my calculator, maybe I get this green piece here. And then if I graph the negative one, so if I graph the positive one, maybe I get that top green piece. And then I graph as a separate function, so like f2 or y2, depending on what calculator you have, you put the negative out in front, so negative square root of negative x squared plus 625, and you would get the bottom part of the circle. So it'd actually be two separate functions. I know that doesn't look like a circle, but let's just assume it does. And then you graph this line y equals negative x minus 31. So it has a y-intercept of 31, and so that line would look something like that. You get a couple of answers, but you can graph them on your calculus. So just know how to solve systems. You got substitution, you got elimination, you got graphing. But notice, all of these were equals, so we were just finding the intersection points. The other thing we did in this section is, what if it doesn't say equals? What if it says, graph the solution set or solve this thing, but now notice they're all inequalities. If they're all inequalities, then the lines themselves are not the answers, or they're part of the answers, but also we're going to shade the areas that also work. So when we graph this first equation, to get y by itself, it would say y equals, if we subtract the 4 and divide by 2, we'll end up with negative 2x, right, plus 3. So if we graph that one, it's right here. It has a slope of negative 2, so down 2, and to the right 1, this is a negative slope. So there's our wonderful line. And then we're like, which side do we shade? And I'm not going to finish this entire problem off, but it's like, where do I shade? And I should have kept this inequality with it. So if I went through and got y alone, it's really y is greater than or equal to negative 2x plus 3. Anytime it's a line being greater than, it has to be above that line. So everything above that line right now is everything up here. So if I were to shade, I would start shading everything on the top side of this line. Now, if that doesn't work for you, then you can test values. Or if you can't see above or below, you can test values. They're always a good point to try is 0, 0. So I'm going to try 0, 0 into this equation, or inequality, sorry, and see if it's true. I'll end up with 0 is greater than or equal to negative 2 times 0 is 0 plus 3 is 3. Is 0 greater than 3? That is a false statement. If that's a false statement, then the point that you tried, whatever region it's in, does not work. Well, that red dot is definitely below this blue line. So everybody below that blue line doesn't work. So that means everybody on the other side of the blue line must work, which is the same answer I got by just saying, you know what, let's just look for greater than. So greater than means above. And then the or equal to means the line actually works, so it's solid. If it just said greater than and did not have a greater than or equal to, this would be a dotted line. We're going to graph these other lines as well, and then we're going to find the intersection of that shaded region. Maybe it's a triangular region, whatever it may be, we would shade that region. So let's kind of quickly do this one actually real quick. I'm going to move the y over to the other side, so it's going to say x minus 3 is less than or equal to y. So I'll just do a little algebra to make that happen. If you read it from the y, this says y is greater than or equal to x minus 3. So even though the inequality is flipped, if I read it from the y, this still says greater than, so I still want above. If I go graph this line, 1, 2, 3 is right there, has a slope of 1, so up 1 and over 1. I'd quickly draw a line through there, and this is still pretty bad. Oh, that was bad. I should have hit 3 on the other one. But I want to shade above this one. So above that line would be everything up here. So now, if I were to shade, I would shade everything in this region right over here. But I still have one more to do. Y is greater than or equal to 2. Y equals 2, you should know, is a horizontal line. So if I graph a horizontal line at 2, I'll make this one green, I guess. Try to make this perfectly horizontal. Oh, yeah. All right. So there it is, y equals 2. And I want greater than. Greater than that would be above. So now if I finish this thing off by shading the shaded region that works in everything, let's see if I have a highlighter here. I think I do. There it is. And move that and we'll make it yellow. I would shade everything above all 3 of those lines, which would be everything up here. Now all I have to do is flip one of those inequalities and it would be the triangular region. If I flipped the y is greater than or equal to 2, if that were y is less than or equal to 2, then I'd be everything below that green line. So all of a sudden now this would be the shaded region. So I'd be like, oh, no. Now I'd want to shade, in this little triangle. Oh boy, that's terrible. In that triangle region. So it depends on the inequality symbol, of where you shade. So you might need some practice on that. You can go back and look at it. Same thing happened in number 6. You'd also shade that. You'd have a circle, but this is where you'd have to test points because it's not a line. We have a parabola here. We have a circle here, so I would definitely test regions. One thing I forgot to do on this top one up here is to find the intersection points as well. If you need to find the intersection points, which are these 2 points, because the yellow shaded region was correct, to find those intersection points, you use substitution or elimination with the 2 lines that are crossing. So the blue line and the green line, I would probably use substitution to solve that one. and the red and the green as well. So you got to be able to find out where are they crossing by doing some algebra over here. Now you also have your calculator ready on the test, so if you want to plug those lines in and have the calculator find the intersection, you can do that as well. All right, there's just a word problem dealing with it. And the last thing in this section was linear programming. So just to kind of revisit that step, these are the exact notes that you have. I'm not going to go through an entire linear programming problem. Just remember the steps. Define what your variables are representing. And that comes from reading the last sentence. How many packages of each mix should be sold for the center to maximize its income? So I'm going to make X equal the number of packages of, and I look through here, they have a Frontier mix that we're selling and a Trailblazer mix. So this would be like the Trailblazer mix, and maybe Y equals the Frontier mix. It's very important to find out what X and Y should represent, and that comes from that sentence. Step 2, write the function that you're trying to maximize or minimize. It says right here, what is his maximum income? So now I have to look for what makes income. Well, we're selling this something for $9.75 here and $9.50 here. Well, the $9.75 comes from the Trailblazer mix, so it'd be $9.75 for every Trailblazer mix. Well, I made X Trailblazers, so X plus $9.50 for every Frontier mix. So, oops, I was right, Frontier mix for Y, and I just want that to be here. It says maximum. Sometimes it's minimum, so you got to make sure you understand what the question is asking. So it says maximum. Once I do that, I try to find the limiting functions. And the limiting functions is I look through here, and I'm going to do this in blue this time, is I try to find out what am I constrained to. It says the center only has 60 pounds of corn cereal. So one of my constraints is I have to have less than or equal to 60, and this is my corn cereal equation. And then I only have 120 pounds of wheat as well, so less than or equal to 120 is another restriction that I have. But then I start looking for the corn up in the problem. Maybe I'll do that in green. So if we go find the corn in the problem, the Trailblazer mix has 1 pound of corn. Oops, that was supposed to be green. And the Frontier has 2 pounds of corn. So if Trailblazer has 1, it's 1x plus, and then it says the Frontier has 2, so 2y has to say less than or equal to 60 because that's all I have. And if I do the same thing with wheat, I look up here in the equation, it has 4 pounds. Trailblazer has 4 pounds of wheat, so that would be 4x plus, and Frontier mix has 3 pounds of wheat, so 3 for each wheat. And sometimes there's a third restriction, but there are only 2 restrictions in this case. So now I would graph those lines by getting y alone or graph them on my calculator. It's less than both of them, so they would end up being below both those lines. I would shade the appropriate region and then try the critical point. So if we just, I'm not even going to graph them for real. So let's just suppose we had a line going like this and another line maybe going like this, and our shaded region ended up being everything in this green region in here because it was less than both of them. So then I would have to test the points. I would test this critical point, which is a corner, this critical point, which is a corner, this critical point, and this critical point. And I'd have to find those. These two shouldn't, or these 3 shouldn't be bad, obviously 0, 0. But yet we're trying to maximize our income, so we're going to try these 4. This one is going to be a little bit more difficult to solve because now I have to find the intersection of these 2. Now if I do it on my calculator will find that intersection. Otherwise I would have to use either substitution or elimination to solve this, treating these as equal signs because I'm trying to find out where they cross. And once you have those, then you take all 4 of those points and try them in the maximizing function and see which one gives you the biggest income. And that's just the general gist of a linear programming problem. So make sure you know how to do that, or remember that step-by-step process. It's kind of just to revisit this before the day of the final exam, like yeah. Or if you feel very confident in that, maybe you don't need to worry about it. But that's all of chapter 10. That was a quick chapter. Hope that helped out. I would do some review if you need it, and hopefully that helps you on final exam day.